Hi, I'm Bob Hazen. I'm a staff scientist at the Geophysical Laboratory, and I've been working on new ways to visualize how minerals coexist in nature. We're interested in the number of different kinds of minerals. We're interested in which minerals are found with which ones, and it turns out you can use some of the same techniques that people have used for decades in social media analysis. So they're looking at social networks like Facebook or terrorist networks of all things, and you can apply it to minerals. And what you do is you say that each mineral is like a node. It's like an individual person that's represented as a circle in these diagrams. And if two minerals exist together, there's a link between them. And the thing that's so neat is these are really interactive. You can take a diagram like this and you can call up certain ways of thinking about minerals, like how they form. Do they form from a molten state, or do they form deep underground at high temperature pressure, or maybe at the surface through weathering? And each of those can be colored differently, and then we can see for the minerals, in this case it's vanadium. I've got one here for copper minerals, and we can basically look at the copper minerals or the vanadium minerals, and we can see what coexists with what. And what's so really neat about these diagrams is they're completely interactive. They tell us so much about the mineral world we never saw before. This is what I'm going to be talking about at AGU. So we can click on one of these nodes and we can basically say, okay, how does that node link to everything else? And you see all the ties. It gives us information about which minerals coexist with which minerals. And you can just explore for hours and hours. You can go on any one of these nodes. You can pull them out. There we go. Come on now. There it is. And you can see that this particular one is linked to only a few others. And virtually everything that this blue node is linked to are blue minerals. Those, in this particular case, mean minerals that have oxygen in them, but no sulfur. So these are copper minerals of one kind. Over here are what are called sulfates. Those are minerals with oxygen and sulfur. And up here in red are all the sulfide minerals that have sulfur but no oxygen. So we're seeing for all the copper minerals ways of them occurring together, ways that they're segregated that we never knew before. So this is brand new science, but it's also like art. It's just such a beautiful, fun thing to do. So I'll be talking about that at AGU.